There is an animal alive right now whose heart is the size of a small car, whose tongue weighs as much as an elephant, the arteries are wide enough that a human could theoretically crawl through them, and which is, by a factor of 2, the largest creature that has ever existed on this planet. Not the largest alive today, the largest, ever. In nearly 4 billion years of life on Earth, nothing has come close. And the completely insane part, it got this way by eating shrimp. Let me explain. First, the dimensions. Because I think people hear blue whale and nod along without really processing what we're actually talking about. The largest confirmed blue whale measured 30 meters long. That's roughly 3 school buses end to end. Its weight, up to 200 metric tons. To put that in context, the largest dinosaur ever found, Patagotian, weighed an estimated 70 tons. The blue whale is nearly 3 times heavier. The heart alone weighs around 180 kilograms, about 400 pounds, and beats as slowly as 2 beats per minute during deep dives. 2. When it surfaces, that jumps to around 37. The circulatory system that heart is powering contains roughly 8,000 liters of blood. At birth, a blue whale calf is already 7 to 8 meters long and weighs up to 3 tons. It gains around 90 kilograms per day in its first year. Fed by milk so rich in fat it has the consistency of toothpaste. These numbers stop making intuitive sense after a while, and that's kind of the point. So, how did an animal get this big? The answer starts about 50 million years ago, and it does not start in the ocean. The ancestor of every whale alive today was a land animal, a small hoofed mammal, roughly the size of a wolf, that lived along riverbanks in what is now Pakistan. Scientists call it Pachycetus. It doesn't look anything like a whale, but the bone structure tells the story. The same ear anatomy, the same skeletal features, undeniably the same lineage. Over the next 15 million years or so, Pachycetus's descendants became progressively more aquatic. By around 35 million years ago, whales were fully committed to the ocean. Limbs replaced by fins, nostrils migrated to the top of the skull, bodies streamlined for water. Then, about 35 million years ago, the whale lineage split. On one side, toothed whales, hunters, using echolocation to chase individual prey, squid, fish, other marine mammals. On the other side, baleen whales, a completely different strategy. Instead of teeth, they developed baleen, plates of keratin hanging from the upper jaw like a giant comb, allowing them to filter enormous volumes of seawater and strain out whatever was living in it. One group hunts one fish at a time, the other swallows entire schools. But baleen whales stayed relatively modest in size for tens of millions of years. Something had to change to push them toward the extremes we see today. About 5 million years ago, something did change. Shifts in Earth's geology and climate caused a significant intensification of oceanic upwelling, the process by which cold, nutrient-rich water gets pushed up from the deep toward the surface. More upwelling meant more nutrients. More nutrients meant massive blooms of phytoplankton. More phytoplankton meant enormous swarms of krill and small fish. Suddenly, the ocean had more food concentrated in more places than it ever had before. And for baleen whales, particularly the rorquals, the group that includes blue whales, this was the moment everything changed. Rorquals had developed a technique called lunge feeding. They accelerate toward a swarm of prey, open their jaws up to 80 degrees, and engulf a volume of water roughly equal to their own body mass in a single gulp. Expandable throat pouches, long skin folds running along the underside, inflate like a balloon to accommodate the intake. The water gets pushed out through the baleen. The food stays in, one mouthful, half a ton of krill. With food suddenly this abundant and lunge feeding this efficient, getting bigger became an enormous advantage. A bigger body means a bigger mouth. A bigger mouth means more food per lunge. More food means more energy for growth and reproduction. All the rorqual species started growing larger around the same time, but one of them took it further than any other. The blue whale. Here's why. Every rorqual species leans into a slightly different diet. Humpbacks chase fish. Fin whales eat a mix of fish and crustaceans. Sei whales target copepods. The blue whale eats almost nothing but krill, and krill, despite being thumb-sized, are the most energy-dense food source in the ocean. They gather in swarms so dense that researchers have documented individual aggregations containing enough individuals to fill tens of millions of Olympic swimming pools. One documented swarm off Antarctica was 400 meters long, 200 meters wide, and 100 meters deep. When you have access to food in those concentrations, lunge feeding becomes almost absurdly efficient. A single mouthful can provide up to 240 times more energy than the lunge itself costs. But krill aren't available year-round. Their populations explode in cold, nutrient-rich polar waters during summer, then essentially vanish as winter sets in. Blue whales follow them, migrating thousands of kilometers between feeding grounds and breeding waters. During migration, they can go months with little to no food, surviving entirely on blubber reserves built up during the feeding season, which creates yet another incentive to be bigger. Bigger bodies store more energy. More stored energy means surviving longer migrations. Every pressure the blue whale faced pointed in the same direction: get larger. The result is an animal so specialized for one food source that if anything happens to that food source, the entire species is in serious trouble. And something is happening to krill. Climate change is warming and acidifying the Southern Ocean faster than almost any other body of water on Earth. Krill eggs are particularly vulnerable to ocean acidification, the drop in pH caused by dissolved carbon dioxide reacting with seawater. Krill populations are already showing stress in key feeding zones. The blue whale, the most perfectly optimized feeding machine evolution has ever built, is entirely dependent on an animal the size of your thumb that is struggling with changes happening faster than it can adapt to, and that's before we get to what humans did directly. In the 20th century, industrial whaling targeted blue whales with systematic efficiency. Factory ships, explosive harpoons, entire fleets dedicated to a single species. By the time hunting was banned in 1966, the global population had been reduced from an estimated 300,000 to somewhere between 5,000 and 10,000 individuals. That's a reduction of around 97% in less than a century. The largest animal that has ever lived was nearly gone. Since the ban, populations have been recovering. Slowly, because blue whales reproduce slowly. A female gives birth to a single calf roughly every 2 to 3 years. Growth back to historical numbers will take generations, if it happens at all. The one swimming somewhere in the Southern Ocean right now, filtering krill through baleen plates, heart beating twice a minute in the cold, dark water, is the product of 50 million years of uninterrupted evolution. A lineage that started on land, committed fully to the ocean, and kept getting larger until it became something that shouldn't be able to exist, and it almost didn't make it. Whether it does from here is genuinely up to us.